Hello everyone, all of our valid customer, nice to greet you. I hope you are well by the grace of Almighty. Myself Amit Devnath, an international after sales service engineer at SENFENG Laser. Now I'm going to show you the control system of our bending machine. Okay, let's go. So this is our control system. The brand is Delem and the model is Delem-53t. Okay. At first, let's take the manual interface. We have two interfaces. You can see here I have auto and also manual. So now I'm explaining you the manual. Okay, on this page, I'll introduce this technical parameter to you. Here the technical parameter you can see. So here included method, bending length, product position, angle, corresponding alpha 1, and this actual angle. We have two angles. Alpha 1, alpha 2, y1 axis, y2 axis, mute and opening. So I'm going to explain you the bending parameter now. There are four types of bending models in general. You can see we can use air, bottoming, hemming and bottoming together. So normally we use the air bending. So select. Okay, we usually use the first one, the air bend. It means custom angle bending. Okay. Bending length. You can see now the bending length. The bending length is the length of sheet to bend. Okay. If bending 1 meter length sheet, we just input 1000 here. Okay, from here. And if it's 2 meter, then we put 2000 from here. Okay. Next, the product's position. So product positioning is automatically calculated based on sheet length. No need to manual changes from here. It's actually based on the sheet size. So no need to change from here. Okay. Now the angle, you can see. The full name of angle is actually bending angle. Okay. We only need to enter angle degree according to our bending requirements. For example, we just input 135 when we want to bend the sheet into 135 degree. The angle will be recorded in the control system directly after pressing the enter key. Okay. So now I'm going to show you the correction alpha 1 and correction alpha 2. Okay. The correction alpha 2 and correction alpha 1 is to make calibration for the final angle. Okay. Alpha 1 for y1 side. This one is for y1 side and corresponding alpha 2 is for y2 side. Okay. So now alpha, we measure the left side and the real angle is 89 suppose. Then so we need to add 1. If the right side of this product angle is 91, we should set alpha 2 minus 1. Okay. Now y1 axis and y2 axis. Y1 axis and y2 axis is the corresponding while bending. They will be automatically calculated according to angle we just entered. No need to change from here. Now we are going to for mute option. Mute means speed conversion point. At this position, the y-axis speed change from fast to slow. Okay, you can see. We can make adjustment manually from here. The current mute position is 185. You can see from here 188 actually. You can see. So we can change manually from here. We mean slow down in advance. We can change it 150 also. While bending, the punch and die will close, so the opening is the distance the punch rises after the bending action is completed. Okay. Now I'm going for the force option. In the force option, you can see have force, drill time, and decompression. Okay. The first is force. Force is automatically calculated. You can see this is automatically calculated from the sheet length, thickness, material type, okay, as well as notch welds of lower mold. Generally no need to change, but if you need to define force in actual work, manual change is also possible. Okay, sometimes the calculated pressure may be not enough. We can increase it by ourselves. For instance, we can change it from 100T, from here 100T to 120T. Okay, now dual time. Dual time, you can say from here, dual time at this time, hydraulic system will keep this pressure output. Okay, we enter 0.1 second actually for a thin sheet. For a heavy thickness sheet, we can set it 1 second or 2 seconds. Now decompression, you can see in this position no need to do any adjustment. Okay, this distance automatically calculated by the system. Next, speed. In this section you can see have speed and decom speed. Okay, there are two kinds of speed here. You can see already on the display. The first one is working speed after mute position, this one. And second one, decompressed speed, no need to change manually. This one, we no need to change manually. Okay. Then we have function here, you can see. Now on the right side, you can see have product properties, tool, auxiliary axis. Products properties, you can see here have the thickness and materials. So normally for the materials and thickness, they are very important. For the materials, we have 4 types of materials here: steel, aluminum, zinc, and stainless steel. Okay, suppose we are selecting stainless steel. Okay, so when I choose one of them, the control system will output corresponding bending force and deflection compensation. Okay, now we have tools. Inside the tools I have 2 options, punch and die. So punch and die we need to edit before use. Just click to punch to select, then it will be shipped to punch library. Okay, this is our punch library. You can see we can add here more function by ourselves, no problem. And the die, this also applied to die. In the die library, select the correct die. You can click here and you can choose the correct die, and suppose select here, it will be choose automatically. Okay, now the auxiliary axis, here you can see have x-axis, retract, r-axis, deflect, and lay on. Okay, regarding to auxiliary axis, we should edit these parameters. If we enter figure and press the enter key, it will be confirmed. Taking r-axis as an example, it defaults as 0 position. You can see the position is 0. This is for an example only. Okay, actually we are taking the r-axis as an example, but when we feel like bending some special workpieces that need r-axis move up and down, actually this r-axis is work up and down position. Okay, we set a certain position. If we input 5, suppose if we input 5 here, it will go up for 5 millimeter from 0 position. If we set here -5, it will be down from the 0 position. It's -5. It means 5 millimeter will be go down. Okay, so we can choose from here and customize from here. Now defect. Defect means, you can see the interface of defect. Defect means deflection compensation. When the workpiece is longer, the angles at position Y1 and Y2 can reach the set angle. Okay, from here, actually from here 5 figure. That means if you choose 5, it will be count 1 degree angle. Okay, so normally if we choose the angle of the middle section does not meet the requirements, in that case, so we have to compensate for the deflection. However, what we need to know in 5 figure are equal to 1 degree. So I already explained you. If you choose 5 from here, it will be count 1 degree. If you select 10, it will be count 2 degree. Okay, so if we want to bend 90 degree, the result Y1 and Y2 is 90, but the middle parts may be 91 degree. In this case, the deflection compensation figure is automated calculated as 21. So we should increase this figure to 26. Suppose if we have here 21, then we need to choose is 26. But we have now 9, so we have to add 5 with this, then the count will be 14. Okay, so in this system we can change. And if our degree will decrease, for deflect every increase of 5, the middle angle decrease by 1 degree. Okay, and for the increase case, we have to increase 1 degree. Suppose if 91, then we can decrease 1, and for 89 we can increase 1. 1 means 5 figure. Okay, I hope you can understand the details. This is our details explanation of manual interface. Maybe next time we will explain the auto interface from here. So thank you for your attention. Okay, so this is all about the manual interface of our control system of bending machine. Later I will explain you the auto system. Okay, thank you for your attention. Take care. Bye bye.